Okay, so welcome to day 3 of lesson 1.1, and we are going to be looking at square roots and cube roots. I'll let you read through the square roots, a positive number. Let you read through all that, but I want to do a couple of examples here. So if they happen to ask you the square root of 25, you want to think what number multiplies by itself to give you 25. Do you know that number? That's right, 5. Positive 5 times positive 5 gives you 25. But there's another number too. There's another number that will multiply by itself to give you positive 25, and that is a negative 25. So a negative 5 times a negative 5 gives you a positive 25. So if you were asked for the answer, what is the square root of 25? Well, you've got a positive 5 and you have negative 5 because those are your two answers. Okay, let's do another example for square roots. So what if they give you the number 16? So think about that. You've got a couple sets of numbers that multiply to give you 16. You've got 2 times 8, and you have 4 times 4. But remember, when you want a square root, they want you to use the same number. So you're going to have to use 4 times 4. So one of your answers would be 4. But keep in mind, you can also take a negative 4 and multiply it by negative 4, and that'll give you this positive 16. But I don't want to write a negative 4. I just take this positive 4 and I say, okay, I have a positive 4 and a negative 4, and that's enough to show your answer. I paused there because I wanted to clean up the screen. So now we're going to look at cube roots. So cube roots, they're going to be a number that's used 3 times to multiply to get a target number. So let's see. A cube root is positive number. Okay, so a cube root's a positive number, it says. So a perfect cube is a number such as 8, because 2 times 2 times 2 gives you 8. Remember, when you have a cube root, you want 3 numbers. Let's try another one. Let's try 64. 64 is a perfect cube because that's 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. Another perfect cube is 125. That's 5 times 5 times 5. So perfect cubes. So I'm going to pause again and clean this off and then talk a couple other things. In both square roots and cube roots, you're going to be presented with fractions. You're going to be presented with fractions. Don't let them bother you, because what you do, if they ask you to find the square root of 4/25, all you do is think about, okay, so what's the square root of 4? Think, what's the square root of 25? Well, the square root of 4, that can be a positive 2 and a negative 2, because 2 times 2 gives you 4, and negative 2 times negative 2 gives you 4. Think about 25. So what's the square root of 25? Well, 5 times 5 is 25, but negative 5 times negative 5 also gives you 25. So you must consider for your answer the positive and negative numbers. And so your solution is written like this. positive and negative 2/5. That would be your solution. Take your time on these. Don't try to hurry. And I think what a very good reference would be get a piece of paper and put down a number and then square and then cube. Put the number 1 down. What's 1 squared? Well, that's 1 times 1. What's 1 cubed? 1 times 1 times 1. So then you have something to reference. The number 2. What's 2 squared? It's 4. What's 2 cubed? Well, it's 2 times 2 is 4, times 2 is 8. Put the number 3 down. What's 3 squared? Well, 3 times 3 is 9. Okay, 3 cubed. 3 times 3 is 9, times 3 is 27. And you're saying, okay, but how am I going to use this? I'll show you. If you need to find the square root of 4, look at your square column. There's the 4. What's its square root? 2. If you want to find the cube root of 27, they used a 27 in their example. They wanted the cube root. We'll go down the cube column. There's the 27. What's its root? 3. And you can have this paper and you can reference it all the time. Or every time you have a problem with cube roots or square roots, you can work them all out every single time. Me, I think having a reference paper is so much faster. Okay, some quick little examples here. We're going to have x squared equals 121. This is an equation. It has an equal sign. So x squared equals 121 is our problem. So what you want to do is find the square root of x, which is simply x. You want the positive and negative. So what number multiplies by itself to give you 121? That would be 11. This could be added to your list. Go down 11, put the 11 down, and 11 squared is 121. So your solutions are positive and negative 11. This is how you write them. Here we have x squared. Find the square root of 16. Find the square root of 169. Well, from your list, the square root of 16 is 4. From your list, make it go up to 169, and 13 is your square root. Positive and negative 4/13. Don't let fractions scare you. It's actually 2 little problems together. Okay, these babies want cube roots. What number multiplies by itself 3 times to give you 729? And that number would be 9. So 9 times 9 times 9 gives you 729. So that would be your cube root. They want the cube root of 8 over 125. So we simply find the cube root of 8, the cube root of 125. So the cube root of 8, that was from our list. 2 times 2 times 2 gives you 8. For 5, 5 times 5 times 5 gives you 125. But all you need are 1 set. So take that 1 set and put it in your fraction. All done. Okay, your turn problems. So they want square root. They want what number multiplies by itself once to get 196. Square root again. Cube root, you're using it 3 times. Cube root, you're using it 3 times. Pause and try them. And yeah, you might make a mistake. It's okay. But use that list that you have. Maybe you made a list. If you did, this will be easy cheesy. All right, the answer for number 7 is 14, because 14 times 14 gives you 196. The answer for number 8 is 3/16. Remember, just do these one part at a time. 3 times 3 gives you 9. 16 times 16 is 256. You should have your list, and you should have 16 as part of your list. So on that column where I have the number symbol, it should be part of your list. Next up, what number multiplies by itself 3 times to give you 512? And that number is 8. 8 times 8 gives you 64. 64 times 8 gives you 512. Number 10, what number multiplies by itself 3 times to give you 64 and multiplies by itself 3 times to give you 343? Well, that would be 4 and 7, because 4 times 4 times 4 is 64, and 7 times 7 is 49, times 7 again is 343. Remember, you might make a mistake, but you want to try these. You don't just want. So this next part is irrational numbers, and you're going to be estimating them. Remember, irrational numbers cannot be written in a fraction. So they cannot write these numbers in a fraction. The square root of 2. So they want you to estimate them. Now, I'm going to let you use a calculator on these. I'm not going to have you multiply them all out, but I am going to go through the steps here so you can see what they're referring to. So they want to know what 2 consecutive perfect squares the 2 falls between. So when you had that number list of yours, and you had the squares, remember 1 times 1 was 1, 2 times 2 is 4, 3 times 3 gave you 9, etc. So they want to know, where does a 2 fall in the squares column? The 2 falls between the 1 and the 4. So you'd say, okay, the 2 falls between a 1 and a 4. And they said, okay, but what if we take the square root of everything? The square root of 2 is what we can't find right now, but we know it falls between the square root of 1 and the square root of 4. So what is the square root of 1? Well, if I have a 1 in my squared column, I want its square root. The square root of 1 is 1. And again, if I have a 4 and it's squared, I want its square root, I want to go backwards. Here's the square, go backwards, its square root is 2. So I don't know what it falls, exactly what square root of 2 is, but it falls between the number 1 and the number 2. So on a number line, if you had this number line, I know it's not the best, but if you had this number line, the square root of 2 falls someplace in here. So we know the square root of 2 is between 1 and 2. Okay, and this is where I'm just going to let you take the square root of 2 on a calculator. I'm not going to have you do all these, because what you'd have to do is take 1 and 3/10 times 1 and 3/10, 1 and 4/10 times 1 and 4/10, 1 and 5/10 times 1 and 5/10. It takes a long time, and I really don't think you're going to need to do this for the PSSA. You'll be using a calculator most of the time next year, so I'm going to use a calculator on this. But I will ask you those questions of what numbers it falls between, and we'll do more of those in class. So from here, what you're going to do is, with your calculator, you're going to put in the square root, and you're going to put in a 2, and then hit equals. And up's going to come a number that kind of goes on and on and on and on. I'm going to write down a few of the digits, but it's going to keep on going after this. And one thing I'm going to ask you to do is I'm going to ask you to put it on a number line. So where would this number fall on a number line? You have to label it so I know where it is. And I might ask you to round it also. So let's put it on the number line first. So we have 1 4/10. But there's a little bit afterwards, so it's not exactly 1 4/10, and it's not 1 5/10. It's someplace in between. Now is 1 4/10 plus 1 4 and 2 and blah and blah and blah. Is it closer to 1 4/10 or 1 5/10? Well, let's see. Let's just consider this part as if it was money. $1.41. So is $1.41 closer to $1.40 or $1.50? Yeah, I'm thinking it's closer to $1.40. So I would place that right here, and I would label that square root of 2. And if I asked you to round this to the nearest hundredth, this is the hundredth. You look to the right and there's a 4, and it says you stay right where you are. So if I said, okay, round this to the nearest hundredth, I'm going to run out of space here, but it's hundredth. You'd have 1 41 hundredths. You have to know how to do that. Okay, so pay attention because you're going to have problems like this for your homework. You're going to go on to My HRW. You have problems like these guided practice on page 12. You have problems like this for your homework. So let's do 13, 14, 15. 13 says x squared equals 144. So what must that number x be? What number is multiplied by itself to give you 144? And that answer, ladies and gentlemen, is simply 12. So the square root of 144 is 12. Positive and negative. Don't let these fractions scare you. Say they want to do the square root of 25 and the square root of 289. They say use the positive and the negative. The square root of 25 is 5. And the square root of 289 is, what would the number be? I can't tell you everything. I'm listening. Okay, it's 17. Good job. Alrighty, and then cube. So the number is going to be used 3 times. What number is used 3 times to get 216? So what number is used 3 times to get 216? So what number is multiplied by itself 3 times? That would be a 6. 6 times 6 is 36. 36 times 6 is 6. Alrighty. Remember, you can slow these down and back them up and stuff like that if I'm going too fast. Now, oh yay, oh yay. Look on 16, 17, and 18. It says, without a calculator. No, you're going to use a calculator for me. So find the square root of 5, square root of 3, square root of 10 to 2 decimal places and write those in. Pause. Okay, so the square root of 5 is approximately, this means approximately, is approximately 2 and 24 hundredths, 2 decimal places. Square root of 3 is approximately 1 and 73 hundredths, 2 decimal places. The square root of 10 is 3 and 16 hundredths, 2 decimal places. I do expect you to say these decimal numbers correctly. This is not 1.73. Oh no. It's 1 and 73 hundredths. And if all you're doing is copying these down and not trying them, not seeing them on the calculator, you're going to have a very tough time when you have to do these on your own. So please don't copy. You're going to have your homework, which is going to be My HRW. So look there. There's just maybe 4 or 5 problems. That's it. Bye-bye.